Okay, welcome everyone to this session. And I'm going to talk here about performance improvement in SQL Server 2022. So I was doing a poll here in the app, and when I checked here a few minutes ago, there was about 45 responses, and about half of you have been using new version of SQL Server in production. And about another 25% has been using it in development tests. So in this session here, I'm going to go through some of the biggest performance improvement in a new version. And this is based on experiences. I work in a bank, investment bank in Copenhagen. My name is Hallengren. And we have been running SQL Server 2022 in production for critical trading systems for about a year. This is like based on those experiences. Okay, here's some more information about me. I'm also a Microsoft MVP since about 10 years. And here's also my email address. If you have any questions after either here after the session, or I will be here all day today and tomorrow. So just please come up to me if you have any questions. And you can also send me emails after, after the conference. And a big thanks to the sponsors here that's supporting the conference. Okay, so here I made a list of some of the improvement in SQL Server 2022. So I'm going to go into improvement around availability groups. They have this new parallel redo thread pool. We're going to look at improvements in temp DB around SGAM and GAM pages. There are improvements around the buffer pool scans is now in parallel. ADR, another big area of improvements, was announced or released in 2019, but there was further improvement in 2022. And also some improvement to stack dumps that was actually introduced in CO8 that we're going to go into. And then there are some improvement that is more related to the optimizer, intelligent query processing, as they're calling it now. So there's something called parameter-sensitive plan optimization. That is, you can say, an attempt to solve the parameter sniffing problem. There is improvements around memory grant feedback. Also, some of the other feedback features, canality estimator feedback and DOP feedback. And also some improvement around plan forcing and some improvement around automatic plan correction. And finally, query store hints. So I'm going to go into each of those features and I'm going to look at what is the problem? I mean, why has Microsoft invested in this area? What problem is it solving? And how is it doing it? What's the solution? And some, go into a little bit more how it works and also share some experiences with each of these improvements. Some of the improvements or new features are really good. Some of them is, you can say, a bit less value. But yeah, let's go into it. Okay, so availability group parallel redo thread pool. So what is that? So when availability group was released in 2012, then the redo process was a serial process. So how it works is that transactions are coming in on the primary, they are sent over to the secondary, and then there's this thing called a redo process on the secondary. That's like reading the log file, transaction log, on the secondary, and like moving the data into the data file. And that was a serial process. And that was like a performance limitation. And then in 2016, they came up with, you can say, an improvement to make it parallel. The problem was that they only had certain number of threads in total on the server that they can use for this, availability group redo. And the problem is that you can say they allocated a certain number of threads for each, you can say basically each database, right? And that meant that you can only get parallel redo for certain number of databases. After this number of databases, you got serially redo. So I think that in our environment, we got parallel redo maybe for 6-7 databases, and then any database after that, you got serial redo. And this was a bit unpredictable because it was like based on the startup order. So databases that started up the fastest, they got parallel redo. So you could let's say that you have 6 databases, you had really good performance, and then maybe you're creating a few other ones, a few new ones, and then suddenly some of the databases that you had before, they start to get the serial redo instead of parallel redo. So that made it very unpredictable. So what I've been doing now is that instead of allocating threads for each database, they have like a whole pool of threads that's like, you can say, shared between all databases. And then you can say, as databases needs redo threads, they just take it from the pool. And that means that those databases that needs the most threads, they will get all the threads that they need. And databases that have very little activity, they don't use that many threads. So it's much better design. And I can show you here how it's. So this is a measurement from one of our big systems. So this is a server with 144 logical cores, one of our trading servers. And I was looking here at 3 databases over time. And you can say we have number of threads, and then we have over 24 hours. So here we have 24 hours, here we have number of threads. So here you can see this database here is very active. You can see that it's using at most 17 threads, and it's using that almost all the time. There's a few periods where there's less, but most of the time it's using the max number of threads. And then we can see the one in the bottom here. You can say most of the time it's only using a single thread, right? And then there are spikes where it's going up to those 17 threads that seem to be the max it can get. So you see, this is much more efficient. The database that is, have a lot of activity, that is getting a lot of threads all the time. The one that has almost no activity, then it will not use up so many threads, right? And this one is something in the middle. They have some kind of spikes here where there's, there's a lot of activity. It could be a batch job that's running. Seems to be some kind of interval, so it could be a batch job that's running. And then it needs a lot of reader threads, and it's getting it. And then between there, it's using a bit less. So I think this has been a very good improvement in SQL Server. And if you want to see how it works, here's a query. So this query, you can use even in the old version of SQL Server to see how many reader threads you're getting. So by using this, you can see in the old version, you will see that number of reader threads was like static. For each database, you can see how many threads you were having. For the new version, then you can see that going a bit up and down. Any questions about this feature? Okay, let's wait for a microphone here. It's coming here.
Why it was 17? Couldn't it be higher, or there was a limitation still?
I mean, this is basically the Microsoft algorithm, how they made it. So they only allow a single database to get a max 17. I don't know the reason for that. Could be that it's not scalable over that number of threads, or it could be that they don't want a single database to use up all the threads. I don't know the reason for that, but that's like the algorithm. So it's basically a little bit similar like before. Before you got 16 threads for each database. Now you get 17, so it's about the same max. Only difference is that before you were using the same all the time, and now it's more like dynamic. You're using the threads when you need it, and when you don't need it, someone else can use them. And it's called, sorry.
Thank you.
Yeah. One other question here?
Yes. Hey, good morning, Ola.
Good morning.
Over here. Just a question about the threads. Will they be used from the thread pool, or is it dedicated threads only for the availability groups?
So my understanding is that there are a certain number of threads that are allocated to this.
So it's taken from the total of thread pools, depending on the number of
I think, it's, of course, it comes after the total thread pool.
Yeah.
But my understanding is that there are a certain number of threads that's like allocated to this, just like there was before. Before you can have, I think it was 100 threads in total.
Yeah.
I don't know for sure it's the same now, but my understanding is that they have certain number of threads that are allocated to this, right? They don't want to, there are other work to do also, apart from redo, right?
Yeah.
So they have certain number of threads. I'm not sure if it's 100 or what it is, but certain number of threads for the redo, and then that is then allocated dynamically based on the load on databases.
Yeah, but they're taken from the total number of threads you have, depending on your CPUs, for example.
Yeah. Of course, it comes from the total number of threads you have on the server, right?
Yeah. Thank you.
Yeah. Okay. Let's proceed to the next. Okay, so Microsoft has been doing a lot of investment in improvement of TempDB over the last few releases. I think it's been a big problem for a long time that you're getting contention on TempDB, and there's been a recommendation for a long time to create multiple files in TempDB. In SQL Server 2022, they addressed the thing that is called GAM pages and SGAM pages. So basically, instead of just allowing, you can say, a single thread or single session to update one of those pages, they can now do like concurrent updates. So meaning that you will not have this kind of contention anymore. So that it's like a really, really good improvement. And we don't have any measurements, but we have not experienced any incident related to TempDB after we went to 2012. And before we had, every few months there was some critical incidents related to TempDB. So I think this is really, really good improvement. Okay, going into the next feature here, and that is around buffer pool scans. So there are certain situations, for example, when there is a failover, when there's a database backup, when you do a checkDB, then SQL Server needs to scan the entire buffer pool. And you can say that's not been a problem if you have small servers. But now companies start having very large servers with terabytes of memory. And then this has become a problem, that it can take a really long time to scan the entire buffer pool. And in our experience, we were having one server with, I think, 3 terabytes of memory. And we could see that the failover during the failover, it was spending 3 minutes just scanning the buffer pool. That's a lot of time in a failover, right? So Microsoft has addressed this now by making this buffer pool scan parallel. It is in basically all the storage engine improvement. They are in, you can say, all editions of SQL Server. You can also measure it. There is an extended event called buffer pool scan complete, and that was also added to 2019. Then you can actually see, whenever there is one of those buffer pool scans, you can see how long time it took. So you could basically enable it before you upgrade, and then you can see if you see any improvements. But I don't have any direct measurement, but I think it's really good improvement. And then there's ADR, Accelerated Database Recovery. So can I ask you, how many of you have enabled ADR on your databases? Okay, so this was a feature that was introduced in SQL Server 2019, and it's basically trying to address several problems. So one problem is that if you have long-running transactions, that can take a real long time when you let's say that you have transactions been running for several hours and then you abort it. Then it can take a real long time to roll back. Another problem is that recovery. I think most of you have seen that sometimes you had some big transaction running and then maybe server getting restarted, and then you see recovery process. You can see in the hour long phase 1 and how many percent and so on. And that can sometimes take many hours. This they're also trying to address with this feature. And the other thing is that transaction log. If you have long-running transactions, for example, index rebuilds or other long-run transactions, then basically the transaction log can grow very large. So this is like the goals with this feature. And they introduced something called persistent version store, PVS, and that promises that you will get very consistent and fast database recovery. You should get instant rollbacks, and you should get, you can say, much more aggressive log truncation. And all you need to do is to enable it on the databases like this. They have done further improvement in SQL Server 2022. Overall, it's a really good feature, especially in 2022. For example, now they even have, before they were just, so what happens is that with this persistent version store, it just keeps creating versions. So just like you have version store in temp2be, you have now a version store you can see inside the database that is persistent. And it keeps creating versions there. And then it's just using that for example, recovery and rollback scenarios. But it needs to clean up all the old versions. And before in 2019, that was just a serial process, or just single redo, single thread to do this cleanup. And now in 2022, there's multiple threads for that. So more efficient, better scalability if you have high load on the systems. There is one thing to be aware of with this feature, and that is if you have long-running transactions, then this persistent version store, this will start growing. And that can impact performance, for example, for your selects. So we have had a few incidents related to that. And so basically what happens is that you have long-running transactions. This persistent version store is not doing any cleanup. And then you can see performance impact on some queries. So what we have been doing is that we have started monitoring for long-running transactions and try to avoid that. But overall, really good feature, but it's just something to be aware of. And there is a DMV here where you can follow how big is this persistent version store for different databases and some other good information. Okay, let's take some more questions, if there are any. Okay, any online questions? Okay. Okay, there's also some improvement around stack dumps. So, as you know, sometimes it happens that SQL Server, when there is an exception or maybe a non-yielding scheduler, then SQL Server is generating stack dumps. And this is like for, you can say, debug purposes for Microsoft. You can open a support case and then you give them this stack dump, and then they can try to find out about what happened. Right? There are mini dumps, and then you can also enable something called filter dumps. Those filter dumps, they're much larger, they take longer time to generate, but they're much more useful for the product group to debug the issues. The problem is that those filter dumps, they can take a real long time to generate, and they can be real large. Now in 2022, CO8, then they have improved this stack dump process so that it's now compressing dumps in memory, and it's also multi-threaded. So they are much faster and they are much smaller. So a little bit of a niche feature or niche improvement, but really beneficial. And you can see it. If you enable this feature, you need to enable a trace flag for now in 2022. Then you can see in this SQL dumper log, then you can see here the compression rate. So this is from one of our servers. We saw that we got 92% compression rates. So yeah, really, really nice improvement. Okay, so now we're going into the optimizer features, intelligent query processing. So I think most of you that have been working as a DBA are familiar with this problem called parameter sniffing. You know, basically you can say SQL Server for each query has like one plan in cache, and you can say you can have, you know, let's take an example. You had, you know, an order table, and you have some customers with large number of orders, and then you have some customers with fewer number of orders, maybe just a few orders. And then, you know, the best plan is not the same for those customers with large number of orders and the customers with few orders. Maybe you want to do a scan for the customers with large number of orders, and for most normal customers, you want to do a seek. Right? This has been like the classic problem for a long time, and it's been really difficult because, you know, Microsoft can only have like a single plan in cache for a single query. And sometimes you run into a problem. Let's say that a plan was going out of cache, and then you got an execution or query execution for these customers with large number of orders, and SQL Server generated a plan for that. And then, you know, that plan got stuck in cache. Right? And then you got all the other executions for the normal customers with few number of orders. And they also got this plan that was maybe a scan plan. So what Microsoft has been trying to do here is basically to say that, okay, we have this query here. Instead of just having one plan, they create something called a dispatcher plan. So basically having multiple plans at the same time for a single query. So they create this dispatcher plan, and then they have those what they call query variants or plan variants. So for each of those variants, if you have one query, there can be, let's say there are 3 of those query variants. Each of them can have their own plan. So here's the picture I was taking from documentation. So we see we had a query here. We had a dispatcher plan, and then let's take the example again with orders. We can have some customers with very large number of orders. They will then get a scan. We have some customers with few number of orders. They will get a seek, and then we have some things in the middle. And you see it can also affect the memory grant. So basically, they keep those 3 different queries, or query variants. When a query coming in, they try to see, okay, which of those variants is it? And each of those will then have a, you can say, one plan in cache. And it looks like they have like, you can say, 3, you can say, variant for each predicate. So you can say small, medium, large. And they can do it in total for 3 predicates. If you have more predicates, more parameters, then they will only pick 3 of them where I think that is, you can say, that is the most problematic, where this feature could be the most beneficial. Right? There are some limitations. Let's see here. There are some limitations. It only works for equality, not greater than or smaller than. Only for equality. It's overall, I think it's a really useful feature. You can see here in Query Store, you can see here how many of those query variants you're getting. That's a way to see, you know, how often this feature is like kicking in. There's also some implications in Query Store. You can say before this feature, you can say query coming in, to Query Store or to SQL Server. It's getting stored in Query Store. Inside Query Store, you will get one query text, and then you can get one or multiple plans for that query. Now with this PSP feature, it's getting much more complicated in Query Store, because now suddenly you have all these variants also. And each of those variants will basically be its own query and its own query text. And on top of that is this, you can say, dispatch or parent query. And each of those query variants can have one, you can say, one or multiple plans. So real nice feature, but it makes analysis in Query Store a little bit more complicated. Any questions about this feature? So question was here about the variants, how many variants you can have. So actually, my understanding.
Yes, let me repeat the question. How many variants can we have? Because it said on the slide that we can have up to 3 variants per query.
Yeah, so...
Because the root problem that we used to have with parameter sniffing was the fact also that when we didn't have any plans for a particular query, the first parameter we got could be some kind of like exotic parameter in our workload.
Yeah.
Would get stored, and we would reuse that.
Yeah, that's right.
And is that a problem right now as well?
So what has been documented is that they can do this for 3 different predicates. That has been documented. And we can also see, and it also looks like from the documentation here, that you can say for one predicate they have like small, medium, large. So my understanding is with, 3 predicates, and each of them can be like in 3 flavors. Then there can be 27 variants for a single query at max. You don't need to get so many, but that's my understanding how it will work. And to your question, it will solve this problem with exotic parameters coming in. Yeah, if SQL Server, it meets the, you can say, criteria here of being a quality predicate, and SQL Server decides to, pick this predicate as one of the 3, yes, then it has the potential to solve this.
All right, thank you.
Yes? Okay, let's move on to the next feature here. Okay, memory grant feedback. So this is a feature that Microsoft has been working on for a long time. They actually started already in SQL Server 2017 and then improved it further in 2019 and now further improvement in 2022. So basically this is about, you can say, how much memory a query needs. And you can say that sometimes it can happen that it is requesting too much memory. And then it's like a waste of memory. Sometimes it doesn't have enough memory, and then you get spill, right? Now in SQL Server, in the previous version, they introduced this memory grant feedback. Then there will be like a feedback loop, so that it's like adjusts based on executions. Now they have further improvements, so that they're even persisting it in Query Store. And they're also using a percentile for, you can say, make it work better in scenarios where there's a lot of variations. And you can see this in Query Store. You can see how this is working, how many times it's kicking in and so on, for which query IDs, for which plans, and so on. There's also extended event you can use to track it. They also have another feedback feature called DOP feedback. that is basically about, SQL Server has some degree of parallelism. Sometimes maybe it is more, you can say, higher than what is needed. And then basically this feature is trying with, you can say, lower DOPs and see maybe it's getting just as good performance with a lower DOP, and then we'll stick to that. If it will be degraded performance, then we'll revert back to the original DOP. Unfortunately, this feature, in our experience, we have only seen it kicking in one time across all our databases. So I'm not sure how useful it's been in our environment, but please try it out in your environment. And even this one, you can check in Query Store. And last of these feedback features, called cardinality estimation feedback. So basically, as you know, SQL Server introduced a new cardinality estimator that was in SQL Server 2014. They call that the default. And then they have the legacy cardinality estimator that's been before that. Problem is that you can say for some queries, for some workloads, you can say the old, you can say cardinality estimator, or you can say the assumptions that comes with the old cardinality estimator is better. What Microsoft's been trying to do is that they create a feedback loop, and they are basically trying to assess if a query or workload would be, you can say, work better with one of the assumptions in the old cardinality estimator. So it's basically trying out that. And if that was working better, then it's like keeping that. If it was not working well, then it's like reverting, you can say, to the default assumptions. And how that works is that it is storing hints in Query Store, and then they will be used the next time. So, yeah, looks like a very nice feature. It's not kicking in that often, but yeah, the intention for Microsoft is to try to improve the plans and avoiding those incorrect assumptions or non-optimal assumptions. And again, you have queries here in Query Store where you can check it. So there's this feature here, automatic plan correction. I will not go into depth with that one, but they have been doing some improvement here also in, actually not in 2022 RTM, but in CO4. So if you're using this automatic plan correction, I can recommend that you enable this trace flag here to get those, you can say, additional improvements. Finally, we have Query Store hints. So can I ask, how many of you have been using Query Store hints? Okay, so one person. Okay, so it's actually a really nice feature. So, you know, sometimes you had a problem that you're trying to troubleshoot some query performance issue, and you find out that you're getting a bad plan. Maybe you need to add maybe you would want it to use a different index, or maybe you would want to use an index hint, or maybe you want to use index seek, maybe you want to have a recompile. But you can say if you have your own query, your own store procedure, then it's like easy to add it. But if you have a vendor application, or maybe even an internal application, it will still take some time for developer to change it. How do you do, right? And what Microsoft has been doing here, they are utilizing Query Store so that you can basically, if you have a query ID from Query Store, then you can basically add hints. So what you do is that you execute the query, or the query is getting executed by the application, and then probably already looking at the query in Query Store. And you can see the query ID there. Then you can create this kind of hint for the query. And how you do it is that you execute the store procedure like this. So for example here query 1 with a hint option recompile. And this works with anything that you can do in the option clause. So it is really easy to use and very, very powerful. I can highly recommend you to try it out when you have these kind of problems. I will do a small demo here also in the end. Okay, so I will start here by, I have this database here, wild volume portals. So I am just clearing the procedure cache and clearing also the query store. And then I will execute the query. So you see here we have select star from sales orders. So I execute this query here 50 times. Okay, you can see that was really fast. Okay, so now I'm gonna go here into Query Store. Okay, so you can see now that we have this query here. Select star from sales orders. And we can see that is query ID 21. Okay, so now let's say that I want to add a hint for this one. How do I do? First we can see, are there any hints in advance? No, there are not. Okay, then let's try to add this one. So we add here 21. So I just call this store procedure 21 option recompile. So I added this option recompile hint like this. And now we can see that this hint has been added. Okay, now we're going to try executing this script again and see if it's being used. Okay, so I execute this script again. Okay, now how can we see if it was being used? So one thing that we can check is that they have this one here, last query hint failure reason. It's not reporting any failure, so that's indicating that's been working. But how can we be sure? Okay, so let's do one more thing here. We look at the actual execution plan, and I change it to just a single execution. Okay, so now let's go into the plan here. We look at the XML, and then we can search here for hints. So now we can see that there is this hint here, option recompile. So we can see it's actually worked. And we also have this thing, hint ID here, that is, we can say, this ID here. So you see it was being used. And now I just did it with an option recompile, but like I said, you could do it with an index hint or a join hint or for seek or for scan, anything that you can specify in the option clause. So some of you might think, well, isn't there a feature for this already? There is a feature called plan guides that has been in SQL Server for a long time. I'm not sure any of you have experience with plan guides. No, this is an old feature in SQL Server, and it was developed with for the same purpose, but it was really difficult to use. There was also a problem that, let's say that you are creating and been using this feature, and you had created an index hint, for example. Then maybe later you drop this index. What happened then? Well, then the query started failing. That was really bad, right? Now with query store hints, now it's just being ignored. So you can say nothing will fail. You can say this hint will just be ignored. And you can also, with the old plan guides, you can also run into problems if you, for example, had a store procedure and then you created one of those plan guides, then you could not drop the store procedure because you had this plan guide, right? So then maybe you could have a deployment that failed, or maybe you cannot alter the store procedure, right? Now, with query store, nothing will fail. The only thing that happens then, if you change the store procedure, is that you will get a new query ID, and then of course you had a hint on the old one, and that's not being executed anymore. And then the new query will not have any hints. Then you have to create a hint for a new query, but nothing will fail. So it's much more easy to use feature and much more robust than the old plan guides. Any questions about this feature? Does it sound useful? Okay. Any questions online? Okay. So I will go back to one of the features that we talked about before. Okay, good.
So there is a question, what happens if we add a query hint for a stored procedure and the developer changes that stored procedure which will recreate it?
Okay, so in that scenario, then basically you have the hint for the query in the store procedure as it looked before, and that will not be executed anymore. And then basically you can say you don't have, new queries coming into query store with a new query ID, that query will not have any hints. So you can say the store procedure will be executed then without the hint. So if they want to hint again, they have to run this store procedure again, so you can say add a hint back. And you can say that is the drawback with everything with query store, no matter if you're talking about query store hint, or there's also the plan forcing feature, where you can force plans in query store. Everything is based on query IDs. And query IDs, you can say they are related to the query text. So anything that's changed in the query text, you can say then you will get basically a new query ID, and any hints or any plan forcing that you have on the old query ID will not be in effect anymore. It's like the drawback with query store. So you can say that query store is really good, query store plan forcing or query store hints is really good if you're talking about you have an ongoing incident and you want to fix something, and you can fix it really fast without involving developers or anything. But long term, it's better you look at other solution, maybe improving the queries, improving indexes, and so on. Because as you see, it's not really stable over time if they do some small changes to the queries. It can just be some small formatting changes. Another drawback here is that it is, you can say, difficult to maintain this across environment. If you do something in production, how do you take those changes, those plan forcing or those query store hints? How do you take those things and get it back to, you can say, development and test environments? There's no really good way of doing that. So it's really good for like fixing, you can say, ongoing production issues. Long-term, work with developers to improve queries, improve indexing, and so on. So how many minutes do we have left?
That's all. Thank you.
Sorry? Okay.
How many time?
How many minutes we have left?
10 minutes.
Okay, that's good. That's good. That's good. Okay, so I have one more demo. I was not sure before if we had time, so I will go and introduce one demo of one of the features that I was showing before. So I was talking about this, let's go back here, this parameter sensitive plan optimization. So I will go into one demo here. Okay, so again, I have a different database here, PHP demo. So I will clear my caches and query store. And then I'm creating a table here, an orders tables, where you see I have an order ID, that is the primary key, an identity. And then I'm creating an unclustered index here on a customer ID. So let's go ahead and do that. While that was running, we can also see that I'm populating the table here. So we have 1 million orders in total, whereof 999,999 is for customer ID 1. And then there is just a single order for customer ID 2. And you can see it also. And I'm also creating a store procedure. So let's say here, where we just take the customer ID as a parameter, and then basically I'm just selecting from the orders based on a customer ID. Right, so this is the same example as I was giving before. Now let's execute the store procedure. And I execute it here first one time with customer ID 1 that has a large number of orders, and then 100 times with customer ID 2. So now let's see what happens. Okay, so this was going really fast. The other question is here, what happened to the plans? Did I get the same plan in both cases? And in that case, which plan did I get? We know that since this one here was having so large number of orders, we would expect to get a scan here, right? And for this one here, it's optimal with a seek, because each of them, it was just having a single order. But what really happened here? So we go into query store, and I just made a query here that is looking at the runtime statistics and joining that with the plans and the queries for this specific store procedure. You see here, that I was talking about before, the queries in query store gets a little bit more complicated because of those query variants. But let's see what plans I'm getting here. Okay, so we can see that we have two different plans here. And we can see that one has a single execution and one has 100 executions. Now let's look at the plan. Now we can see that the first one was getting a scan. So that must be order ID 1, because that was the one that was, having single execution. And then the one with 100 executions, that is getting a seek. So that's actually really optimal. So let's try to be really sure here, that, find out which of the plans was for which of the customers. So what we can do here is that we go into the XML and we search here for parameter. So now we can see here parameter compile value 1. You can say, and this is the customer ID. So that means that for this scan plan, that was for customer ID 1. And let's see the seek plan. That was for customer ID 2. So you see this actually worked really well. If this was before this feature, then what would have happened here is that to begin with you have nothing in cache, and then you execute this with this customer with large number of orders, you got a scan plan in cache, and then you got stuck with that in cache. That would be the typical parameter sniffing scenario. And then you would have executed it 100 times for this customer that had, only a few orders, but you still have this scan plan in cache and bad performance, right? But you see here that this feature actually worked in this scenario. Now this, of course, was a really simple scenario, and there are other more complicated scenarios where it may not work as well, but you see the concept. Any questions here about the demo and or about this feature?
Do we need to have the query store feature enabled for this to work, or is it only based on the compatibility level?
So my understanding is that it's only the compatibility level that's required. But of course, if you want to be able to see it in Query Store, then you need to have Query Store enabled. But just to get the feature, the compatibility level 160 is enough. But then, of course, then you don't have the visibility as you have with Query Store.
Okay, thank you.
Good. Okay, so let's see if I had any more slides.
We have a question online.
Yeah.
What if we've got more than 3 plans?
Sorry, more than?
3 plans. 3.
Okay, so actually it's not number of plans, it's number of predicates. So predicates is basically the parameters, right? So if you have more than 3 predicates, 3 parameters, then SQL Server will try to, you can say, assess based on statistics, will try to assess which of the parameters are most vulnerable to this kind of parameter sniffing problems. We have like skewed statistics. And then we'll try to pick those 3 predicates where it's, you can say, most risk for running into issues. That's how it's working.
That's all. Thank you.
Okay. And yeah, I put my email address in the end here also. No, let me just... Yeah, here's my email address, so please feel free to send emails. And thank you for attending the session. And yeah, looking forward to meet you here at the conference.